Hello, everybody. Welcome to our next presentation entitled, How Do I Verify My NMOS Solution? And with us today, we have three gentlemen from the UK who were unfortunately unable to join us here in Las Vegas, but we're looking forward to their presentation pre-recorded. So first off, I have Rob Porter, who's a project manager for Sony Europe. Hi, Rob.
Hi, Wes.
We have Gareth Sylvester-Bradly, who's a principal engineer with NVIDIA. Hi, Gareth.
Hi, Wes. Good to be here.
Okay. And we have Jonathan Thorpe, who's also a principal engineer for Sony Europe. Hi, Jonathan.
Hi, Wes. How you doing?
Good. Well, over to you guys. It looks like we've got the presentation up and we're ready to go.
Thank you, Wes. Yeah, and thanks everyone for coming to our talk. So we hope to be able to answer a number of burning questions about AMWA NMOS and testing today. I'll start by answering some questions on what AMWA NMOS is and what the component parts of an NMOS system are. I'll then give a brief overview of the testing resources that are available, including the NMOS Testing Tool. And I'll then hand over to Gareth, who'll tell you a bit more about the NMOS Testing Tool in some more detail and how one can go about testing nodes and registries. Jonathan will follow up to explain how we added testing functionality for controllers and how one can very easily install and run the testing tool themselves. And finally, we'll talk a bit about what happened at the recent AMWA workshop and what's on the horizon for future testing resources and events. So, what is AMWA NMOS? Well, NMOS stands for the Networked Media Open Specifications, which were developed by AMWA, the Advanced Media Workflow Association, as a set of open APIs for managing devices on professional media networks. That is, devices that typically send and receive SMPTE ST2110 video, audio, and metadata streams to each other over a network. And by avoiding proprietary APIs, the NMOS specs allow interoperability between different manufacturers' devices. They're standard RESTful APIs. That is, they use HTTP GET, PUT, patch, and delete with JSON payloads. And they also allow clients to subscribe to WebSocket notifications for updates. Now, the NMOS specs cover a range of functionality for professional media networks. Two of the key parts of this are ISO 4 for discovery and registration of devices when they're connected to the network, and ISO 5 for connecting between the devices. So in the context of testing, you'll hear a lot about nodes, registries, and controllers. So what are these different components? Well, node is the term used to mean any media endpoint that is connected to the network. So this could, for example, be a camera that sends video and audio over the network, or a monitor that receives both video and audio. The registry is a system that is kept up to date with a database of all the nodes that are currently connected to the network. And a controller is a hardware or software device that allows a user to see what nodes are currently available on the network and make connections between them. So when nodes are connected to the network, they first discover the location of the registry, and then they make an ISO 4 registration API call to the registry to get themselves added to the registry's database. Controllers can make ISO 4 query API calls to the registry to find out what nodes are currently available on the network. And then the user of the controller can choose to make connections between the nodes. And this is carried out by the controller making two ISO 5 connection API calls, first to the sending node to obtain information about the media format and transport parameters, and then to the receiving node to pass on that information and allow the receiving node to complete the connection. So how can these NMOS solutions be tested? So having implemented or purchased one of these NMOS solutions, we want to know how we can go about testing it to make sure it complies with the NMOS specifications. And this is a really important point. This is really key to interoperability. If different vendors have implemented the specs in slightly different ways and their solutions cannot talk to each other as a result, then we're in a pretty bad situation. So over the years, there have been a number of industry events where vendors have been able to get together to make sure their solutions can talk to each other. including AMWA and JTNM workshops, pre-staging events leading up to big demonstrations such as trade shows like NAB and IBC, and more recently, JTNM tested events. So JTNM tested was introduced in 2019 as a way for manufacturers to obtain a badge and an entry in a results catalog to say how their solution conformed to the standards and specifications. From the first event in spring 2019, this included data plane testing only, that is ST2110. From the second event, it also included control plane testing, that is JTNM TR1001-1 and AMWA NMOS. But ideally, we'd like everyone to be able to go away and test their NMOS solutions by themselves in between all these industry events, and the NMOS Testing Tool allows this. So this is a freely available tool, available from the AMWA website, that anyone can install and run themselves. And it's the very same tool that's been used by the testing team at those JTNM tested events. And the NMOS testing tool covers the whole suite of published NMOS specifications from ISO 4 to IS10, as well as the best current practice documents, the BCP documents that you can see here. Previous JTNM test events have focused on a subset of these, the ones that are currently most widely adopted and hence most important for deploying IP systems today. That is ISO 4, 05, 08, 09, and BCP 002. And the NMOS testing tool was originally designed to cover tests for NMOS nodes and registries, but there was no facility for controller testing. And in fact, at the most recent JTNM tested event, which was actually a couple of years ago now at the beginning of the pandemic, controller testing was first introduced there, and it was carried out manually, which was quite a time-consuming process for the testing team. So at Sony, we proposed and led a new AMWA activity last year to add semi-automated controller testing to the NMOS testing tool. And Jonathan's going to talk about that a bit later. But first, over to Gareth to tell us a bit more about how the NMOS testing tool actually works. Gareth.
Thanks, Rob. So, how does an end user or developer of an NMOS solution go about using the NMOS testing tool? There are several ways to download and install the testing tool covered in its documentation. We've recently published a short video tutorial as well, so we'll give you a link to both of those later. Having installed the tool on your local machine or another host in your network, the tool provides a simple web front end you can access in a web browser. You select the test suite you want to run and enter the network address of your node or registry. In this example, testing an NMOS-enabled camera, the user will ultimately use several test suites covering the full required behavior of an NMOS node. When you start the test suite, the testing tool makes API requests to your node and checks the node's responses against the specification. In a network media system, a node is also required to discover and communicate with an NMOS registry and handle failover to ensure a robust system. The testing tool therefore also creates and advertises several mock registries. By providing these mock instances, the testing tool can monitor the node's DNS service discovery and its NMOS registration API requests and validate these against the specification as well. And you can test an NMOS registry in exactly the same way. For that test suite, the testing tool creates mock nodes that communicate with the registry under test and then validates the correct behavior of the query APIs. So I think I'll show a little demo of testing a node, if that's all right, Rob. So here is the web front end. In this case, I've used the Docker option to install. Now let's start up an NMOS node and show how we can test it. I'm going to run a software NMOS node, but I'm not going to run it on the same host as the testing tool. I'm going to run a node on my Jetson. I've got the open source NMOS CPP node, so we're going to run that. But first, to work with the default setup of the testing tool, I've just made one important change to the NMOS CPP node config file to force it to use MDNS discovery. Now we can run the node. Notice that the node hasn't discovered a registry to connect to. If you do have a registry on the same network segment as the node under test, that's likely to interfere with the operation of the testing tool, which is why we recommend testing in an isolated network. But back to the browser. First, we'll test the basic functionality of the node. So we choose the ISO4 Node API test suite, we enter the hostname or IP address of the node and its API port, and then start the test suite. This can take a little while to run, about a minute for this particular test suite. The testing tool is making those API calls and checking the responses from the node, and it also includes those mock NMOS services. The testing tool has started the mock NMOS registry, in fact more than one, so that it can test the node's interaction with the registration API. While the test suite is running, we can see the node discovering and using the mock registry in its log. When the test suite is complete, the results are shown in a table and are characterized with a pass, warning, or fail. Not all warnings are important, though. There are some disabled tests here because the testing tool isn't configured to test secure APIs by default. And as I already mentioned, we're starting off here testing multicast DNS, so the unicast tests don't apply. The one fail reported here is because I used the hostname to run the test suite rather than the IP address. And the reason for the failure is shown in the results. And in this case, I'm happy because I know this is just a configuration option I can change. In a network media facility, JTNM TR1001 mandates the use of unicast DNS SD though, and the testing tool allows this to be tested as well. When configured for unicast, the testing tool starts a mock DNS server, as well as the registries, so that it can monitor the node's DNS queries. The operator needs to configure the node to point at the mock DNS server using the testsuite.nmos.tv domain, and everything else then works as before. The documentation includes specific guidance on how to set the testing tool up in this mode and some other more detailed test cases. Right, Jonathan, are you going to talk about the new controller testing capability?
Thank you, Gareth. So the challenge of extending the NMOS testing tool to test controllers was how to semi-automate or potentially fully automate what had previously been a completely manual process. To address this, Sony led the AMWA controller testing activity, whose initial goal was to extend the NMOS testing tool to semi-automate the controller tests that had been conducted at previous JTNM tested events, namely verification of the controller's use of the ISO4 and ISO5 APIs. So here's how the controller testing works. The NMOS controller under test can connect to a mock registry and mock nodes, which are fully under the control of the NMOS testing tool, and so can be easily monitored and manipulated. When running controller tests, the testing tool prompts the operator to perform actions on the controller's user interface via a testing facade, which receives instructions from the testing tool via a Q&A protocol. Changes in the controller user interface are reported via the testing facade for validation by the testing tool. In addition, controller actions can be validated by the mock resources. Here's a short video demonstration. This video illustrates the NMOS controller tests in action. The video shows the testing tool being used to run ISO4 query API tests on the Riedel NMOS Explorer software. The testing facade prompts the operator to perform various actions that require the ISO4 query API. For example, noting the senders and receivers that can be browsed using the controller and selecting the appropriate options in the testing facade's user interface. Once the operator has navigated through the tests on the testing facade, they can view the results that have been evaluated by the NMOS testing tool in the usual way. If you want to use the testing tool yourself, you can find instructions on how to download, install, and use the tool on the AMWA.tv website. And a video tutorial of how to install the testing tool can be found on AMWA's YouTube channel or by searching YouTube for NMOS Test Tool Tutorial. Back to you, Rob.
Thank you, Jonathan. So, as many of you may be aware, we recently held an AMWA workshop that focused on using the NMOS testing tool. This was in collaboration with the EBU, who was supporting security vulnerability scanning at the same workshop. So the aims of the workshop were to educate participants on how to use the NMOS testing tool, to give participants a chance to try it out, ask questions, report issues, to help participants ensure their solutions will interoperate with others, and to help prepare for future JTNM tested events. And additionally, to try out the Greenbone security scanner, which the EBU Media cybersecurity team recommend we all use. We had over 70 participants from over 30 different organizations, and we had really great engagement from those participants. We had 2 well-attended Zoom calls each day where we introduced the NMOS testing tool and how to use it, and got valuable progress updates and feedback from participants. In between those calls, participants could ask questions on Slack, which the organizing team responded to as quickly as they could. So we've collected some feedback from those participants on what kind of testing they got involved in during the workshop and how they intend to use the testing resources in future. So these results show which tools participants were already familiar with before the workshop and what they actually used during the workshop. You can see that node testing was particularly popular, but it was good to see plenty of participants trying out the new controller testing functionality, as well as the EBU's Greenbone security scanning tool. On this side, you can see whether participants had already been using the NMOS testing tool as part of their product development or commissioning process on the left, and also whether they intend to in the future on the right. And you can see that many participants have already been using the tools for this, and all of them intend to do so in future, which is good news. On this slide, the first pie chart shows how many participants had previously taken part in JTNM tested. So that's around half of them. The pie chart shows how they participated in JTNM tested in different ways, either doing ST2110 testing or NMOS testing, or a combination of both. The second pie chart shows how many intend to participate in JTNM tested in future, and that's almost all participants. So it's good to see that in fact, all participants, it's good to see that everyone wants to take part in that in the future. And the final pie chart on this slide shows how many would like to attend the next AMWA workshop, which is really nice to see, 100%. So overall, it was a really positive experience, with many attendees saying that it had been a really valuable week. So Gareth, were there any particular issues raised at the workshop that have led to improvements that could be made to the tools in future?
Yes, I think so. I mean, as you said, it was a really interactive workshop and included both experienced users and vendors, as well as several organizations who haven't participated previously. And the community functioned really well, and we got some useful feedback. One of the requests was for more informative logging during each test case, an explanation in the testing tool output, especially for test failures, obviously. And even during the workshop, we were able to make a contribution on that, and it's something that will be built on. We haven't been talking about the non-interactive mode that the testing tool provides, but this is something that several participants have already integrated into their automated workflows. We'll be updating the guidance to show how to deploy the testing tool in networks without internet access shortly. And finally, we did have just 1 or 2 questions during the week on edge cases in the specs, which we were able to answer. And the nice thing about having an agile process for the testing tool and for the specs themselves is that we can add new test cases and make editorial clarifications in the specs very quickly.
Great, thanks, Gareth. Jonathan, how about the controller testing side of things?
Yeah, so this was the first time that the controller tests have been used in a workshop. And from the feedback of participants, we know that things went well and no one had any major problems when using the new controller test suites. We also had some valuable feedback from participants that we'll be using to improve the testing tool. So for instance, better reporting of failures when they occur. We feel that overall, the introduction of controller tests into the testing tool has been a great success.
Thanks, Jonathan. So what's next? Well, back to Jonathan again. Would you like to say a little bit about how controller testing might progress in future?
Yeah, sure. So currently implemented are test suites that cover the parts of ISO 4 and ISO 5 that were tested in previous JTNM tested events. And the vision is to have controller tests, to have test suites for each NMOS specification. And so to help towards this, Sony recently led an activity in AMWA to help define controller-specific requirements for each of the NMOS specifications. And the aim is then to underwrite these controller-specific requirements with their own test suites.
Thanks, Jonathan. Gareth, could you say a few words about how the rest of the testing tool will be developed in future?
Yeah, absolutely. I mean, I think we've already reiterated that the testing tool continues to evolve and to reflect, when there are any issues, they can quickly be covered and we can cover gaps. And it's also worth saying that it's also part of the formal AMWA specification process to provide test suites whenever new functionality and new specifications are added to the NMOS suite. So this is something that will continue to expand, and we very much encourage people to use the latest versions of the testing tool.
Thanks, Gareth. So further JTNM tested events will be happening in the future, and these will continue to use the NMOS testing tool to perform the TR 1001-1 and AMWA NMOS tests. And we expect the new controller test suite to be adopted at these future events to carry out the controller testing. So please do try out the NMOS testing tool if you haven't yet. And even if you have, let's all continue to use it between industry events and make sure our solutions can interoperate smoothly. Thank you.
Well, thank you, gentlemen. So I thought I might put out a couple questions on behalf of the audience. First of all, is this a tool that you think is going to be used extensively by, let's say, end users, people who have facilities that are implemented using 2110 and NMOS? And is that going to be on a as needed basis, or do you think these things will be run on a regular basis?
I mean, if I could just take that first, we recommend end users use these test suites as well as vendors, developers, and particularly when choosing a vendor as part of your commissioning process, check that their solutions pass the test suites, check them when choosing the solutions, check them when deploying the solutions, and as you say, Wes, when on a regular basis when solutions are deployed, if there's any kind of issues going on, reaching for the NMOS testing tool to check that everything's still operating as required is a wise thing to do.
So are these test things that I have to take my system down in order to run, or can I run some of these tests while I'm live and producing video content for my viewers?
Maybe I can take that one. There are a number of the tests where absolutely it's possible to test a live system, a live device. However, as we mentioned earlier, there are some parts of the testing where you're, for example, testing failover to ensure that you have a robust system, where really you need exclusive use of a network segment so that you don't interfere with any live settings. So that's one of the reasons why running these tests as part of the kind of commissioning process is a good idea.
And what was your sense of the controllers that were tested? I know you're not at liberty to disclose individual results, but did you find that the controller tests, most of the controllers were 90% great and maybe a few tweaks, or is there a lot of heavy lifting that has to be done in order for these controllers to really be able to do their jobs?
So certainly from the feedback that we got, I think that most of the controllers were passing the tests, and I think there were a couple of instances where maybe the protocols weren't quite right, but they, through using the test tool, they were able to correct those. So I think that actually it was a case of things being kind of 95% there, and then the testing tool helped nudge forward. But by using the testing tool as part of their development process, they reach 100%, and that's what we're aiming for, really.
And so if a end user is looking to have a supplier provide a controller and supply nodes from multiple different sources, if these entities can show successfully going through these test processes, you're fairly confident that they'll at least be off to a good start, that they'll be able to do all of the basic functions that they really need to do in order for NMOS to work properly. Would that be correct way of saying things?
Yeah, absolutely.
Absolutely.
Yes.
Yeah, of course, there's no guarantees, right?
There's I guess No guarantees, but this is exactly what we do to have high confidence.
That's great. That's great. And so what do we have coming up in the future, again, for new testing events, and how are you encouraging industry participation? What can people do to dive into this?
Yeah, I mean, if people want to get involved in, closely in this, being a member of the AMWA is a good start. Being a member of the AMWA allows you to get involved in the test development and so on, and also get involved in working groups on some of the specs that are currently being written to extend the functionality of NMOS. This recent AMWA workshop we actually ran as an open event, so non-AMWA members could attend as well, and that was a really good thing to do. It meant we got lots of participation from outside AMWA as well as from within, and so maybe some of those vendors and end users who hadn't had a chance to use the testing tool before, or maybe weren't even aware of it, got to learn about it. So I think certainly in future it would be great to run similar events. In terms of JTNM tested, I know there are plans to hold events in the future. I have no confirmation of when that would be yet, but that's really the key event on the calendar to get your badge and your entry in the catalog to say publicly what your solution does in terms of its support for the ST2110 suite of specs and the NMOS suite of specifications.
Yeah, I see that as being a really valuable thing for everybody in the industry, the users, the system integrators, and the vendors. Getting that badge of surviving the testing process really gives users a lot more confidence that when they plug these things together, they're going to work. So thank you so much for your efforts in those areas, and I look forward to some future events. Just want to say thank you to Rob Porter from Sony Europe, Gareth Sylvester-Bradly from NVIDIA, and Jonathan Thorpe, also from Sony Europe. Thanks for your time, and we look forward to seeing you in person at an upcoming event.
Thank you,
Wes.